In this video, we'll solve a physics problem about finding the depth of a well using the timing of a stone drop and sound travel. Let's read the problem. A stone is dropped down a well. 5 seconds later, the sound of the splash is heard. If the velocity of sound is 1,120 feet per second, what is the depth of the well? Let's visualize what's happening in this problem. We have a well, and we're dropping a stone into it. The stone falls under gravity until it hits the water at the bottom. When it hits the water, it creates a splash sound. This sound then travels back up to our ears. The problem tells us that the total time from dropping the stone to hearing the splash is 5 seconds. Let's define our variables to help solve this problem. We'll use d to represent the depth of the well in feet, t1 to represent the time for the stone to fall in seconds, t2 to represent the time for the sound to travel back up in seconds. We know that the total time is 5 seconds, which means t1 plus t2 equals 5 seconds. Now, let's think about the physics involved. For the stone, we know it's falling under gravity. The acceleration due to gravity is approximately 32 feet per second squared. Using the equation for free fall, the depth traveled is equal to 1/2 times gravity times time squared. So d equals 1/2 times 32 times t1 squared, which simplifies to 16 times t1 squared. For the sound, we know it travels at 1,120 feet per second. Using the basic formula distance equals speed times time, we can say t2 equals d divided by 1120. Since we already have d in terms of t1, we can substitute. t2 equals 16 times t1 squared divided by 1120, which simplifies to t1 squared divided by 70. Now let's combine what we know. We had the equation t1 plus t2 equals 5. We can substitute our expression for t2 to get t1 plus t1 squared over 70 equals 5. Let's rearrange this to standard form. t1 squared plus 70t1 minus 350 equals 0. This is a quadratic equation that we can solve using the quadratic formula. Let's solve this quadratic equation. t1 equals negative 70 plus or minus the square root of 70 squared plus 4 times 350, all divided by 2. This simplifies to negative 70 plus, or minus the square root of 4,900 plus 1,400, all divided by 2, which is negative 70 plus, or minus the square root of 6,300, all divided by 2. This gives us negative 35 plus, or minus 5 times the square root of 63. Since we're dealing with time, we need a positive value, so we take the positive root. t1 approximately equals 4.69 seconds. Now that we know t1, we can find the depth of the well. We had the equation d equals 16 times t1 squared. Substituting our value of t1, we get d equals 16 times 4.69 squared, which gives us d approximately equals 351 feet. Let's verify our answer. First, the time for the stone to fall is 4.69 seconds. The time for the sound to travel back up is t2 equals d divided by the speed of sound, which is 351 divided by 1120, giving approximately 0.31 seconds. Adding these times, we get 4.69 plus 0.31, which equals 5 seconds, matching our given total time. Therefore, the depth of the well is 351 feet. Let's summarize our approach to solving this problem. 1. We define variables for the depth, time for stone to fall, and time for sound to travel. 2. We use physics equations. d equals 16t1 squared for the falling stone, and t2 equals d divided by 1120 for the sound traveling back up. 3. We combine these with the total time constraint t1 plus t2 equals 5. This gave us a quadratic equation that we solved to find t1 equals 4.69 seconds. 5. Finally, we calculated the depth d equals 351 feet and verified our answer. Thanks for watching.